implicit differentiation. We're not going to spend a lot of time. The last time it was on the free response part of the exam for the United States was in 2004. That's 8 years ago. So I think you have a good chance of it being at least part of your free response questions. Okay, I do implicit differentiation when I cannot solve for y explicitly. And sometimes, even if I can, for instance, if I have x squared plus y squared equals 4, okay? I have this type of equation. I could solve for y. But actually, it's equal to 25 on one of the problems, and you're asked to find the second derivative. But if I do that, I would get y squared equals 4 minus x squared, and then we'd square root. Okay, Christian? And I'm hoping I'm not going to see anybody write down 2 minus x, because it's not 2 minus x. Now, what's the square root of y squared? That's the absolute value of y. Natalie, how do I solve that equation? Y is equal to what? Plus or minus. And since if there's no initial condition, I'd have to have both answers there. What's this a graph of? It's a circle. It's nice to know when you look at this one that it's going to be a circle. Okay, that's not easy to differentiate. Differentiating x squared plus y squared is 4 if you don't solve for y first. So if I have x squared plus y squared is equal to 4, then, maybe it'd be worth our while to look at that second derivative. Oops, it's all connected. Sorry. Take the derivative of that. What's the derivative of x squared, but with respect to x? You have to pay attention to the denominator. What's the derivative of x squared? 2x. Okay, Natalie, you need to focus, please. What's the derivative of y squared? Times dy dx. And I like to write that because I lose the primes, for one. And the other thing is, I keep in mind it's dy dx, not dy dy. Because dy dy would be 1. And this is equal to 0. Because the derivative of y squared with respect to y is 2y. Because you're talking about how does y squared change? Well, first, how does y change if I change x? And then, how does y squared change if I change y? That's just the chain rule. That's why I said don't forget the chain rule. So if we solve for dy dx, right? I'm going to get 2y dy dx is equal to negative 2x, and dividing by 2y, I'm going to get y is equal to, and please simplify because it's much harder to deal with those 2's. Well, now that's pretty simple. That wasn't terribly difficult. This one I have to have the halves, I got to do the derivative of the inside, I have to remember about the derivative with that negative sign, so that's probably kind of an issue. Now, on the problem, I can't remember what year it was, but it was x squared plus y squared equals 25. They asked for the second derivative. And they ask it at a point. If they ask it at a point, then once you get the derivative, just plug the points in and don't bother simplifying. So we're going to start with dy dx equals minus x over y. And the reason I'm doing this is because I think some of us forget this. It's the derivative with respect to x. What rule do I have to use? Quotient rule. So the second derivative, you remember what that looks like, right? It's d squared y dx squared. If I have dy over dx quantity squared, what is this? It's not the same thing. What is dy dx? First derivative, and you'll square it. So it's a different thing. Okay, so do you remember how to do the quotient rule? The denominator times the derivative of the numerator minus the numerator, I'm going to show all my signs so I won't mess it up, times the derivative of the denominator. That's dy dx. It's not 1. Some of you want to make it 1. You have to look at what the denominator is. What am I taking with respect to? Over y squared. And now if I know what the ordered pair is, I'll just substitute it in. What would I put in for dy dx?
Negative x over y.
Right, dy dx is this. I would substitute that right in there. That was doing it implicitly. It was easier than doing this and having those square roots, and then imagine that after that, I'm going to have to do it again with square roots. I don't like that. It's not always an advantage to be always an x. Now this equation, it's just my quick little example, you actually can solve for y here, but I have to use the quadratic formula. And a would be -1, b would be x, and c would be this function sine of x. And it's pretty ugly. So it's a lot easier. Why don't we just take the derivative as written? So it's d dx of that product, d dx and d dx. So what's the derivative? You should probably be doing it with me. Of x times y. It's x times, yes, and so if you were here last night, it's a repeat. It's the derivative of y with respect to x. Plus y times, and if you have problems with this, it's the derivative of x with respect to x. They might ask you to take this equation and find the derivative of that equation with respect to y. It is, but if I had asked for d dy, then that would have been x times the derivative of y with respect to y, plus y times the derivative of x with respect to y. And I've seen that. Haven't seen it on the AB exam, but I've seen it on the BC exam where it's the AB part of it. So what they do on BC is they step up the AB part of the BC exam. It's a little bit harder. Not for the BC topics, no. You could get a 5 on the AB sub-score and maybe get a 1 on the BC. You'd have to know some of the BC topics. You know a couple, not very many.
I feel like the only topics we know are derivatives and integrations.
Well, that's all this is, that's right. But then there's branches that go off from there. Okay, guys, what's the, what? Yes. What's the derivative? Shh. Guys, the derivative of sine of x is cosine of x. Remember, the derivative of the cofunctions are the negative ones. That's a regular sine function.
Why is that?
The derivative of the cofunctions are negative. This is not a cofunction, it's sine.
Cosine is negative. Oh, yeah. Sine is
Times, okay, shh, guys, Carolyn, times the derivative of x with respect to x. 1.
What about the derivative of y squared?
But I did it. Oh, I did it wrong. I totally forgot it.
It's 2y.
Too many, we'll do it in green. I forgot it because there's too much chit-chatting. This was the first one, and I also sidetracked. And then what's the derivative of this? Minus 2y dy dx. Okay, so I'm going to clean that up. So this is x. I could call it y prime now. I prefer to see the dy dx in the beginning. I know it's a pain to write, but I like to get things right. Okay. Now, on the exam, Luke, you guys, I need you to be quiet, please. You're not interested? That's fine. But not everybody was here last night. Here's one from last year. And you are given this. I could solve for y, but I don't want to. And I'll never get this answer if I do. I'll never get that answer if I do. So what they do is they give you the answer here. So what I have to do is manipulate with algebra what I just got over here. And if you have problems, what I do is just circle, and you can't bring in colored pencils, unfortunately. I want to circle dy dx. That's what I want to solve for. I'll get rid of everything else. This is strictly algebra. So it's going to be x times dy dx, and I'm going to subtract that y from both sides. And so I'm still going to have minus 2y dy dx. And I think if you know what the answer is going to be, if you have the basics down here, I think you can get to it. Yes?
When they give you the answer, like when you're working towards, can you work backwards? Easier?
I don't think so, because you have to find the derivatives. But you can use that to help you find things. Okay, so we want to solve for dy dx. And you can see it in the answer if I gave you the answer. At least I think you should be able to see it. So I think you can kind of get your 2 points. That's all it is. Dy dx, and I'm left with x minus 2y equals cosine of x minus y. You see, I can combine those. I have to factor them to do that. And then I divide by x minus 2y. This is what I loved about algebra. I didn't have to do the arithmetic. So it's cosine of x minus y over x minus 2y. And they could have said, show that the derivative of my original function up here was equal to that. And this is the work I would use. Now, you get a point for doing the implicit differentiation, and then you get a point for following through correctly from the rest of it. Okay? If they had asked you to find the derivative at a point, then once I got the derivative down here, I would just substitute the point in. Because it's easier for you algebraically. And this is your unknown. Okay, so that's the implicit differentiation. There are a lot of problems. No, actually, not too bad. We have 2004, number 4, and they ask for the second derivative, by the way. So when you do the second derivative and you do the derivative of y, you better call it dy dx. It's the same kind of problem. I'll buy the piece of paper. Otherwise, we can get you started on your quiz. Well, I wrote it down.
Are we going to do 2004 number 4?
No, we're going to take the quiz so you have enough time for the quiz. The quiz is on FTC and differential equations. And there are some things here. You need a calculator for one of the problems. I'll give you the quiz first. I don't know what it is. And I'll then write up which problems you should be able to do.